Happy afternoon to all of you. Welcome back. Welcome back to another session of chemical bonding. Today is day 11, right? Where we are going to discuss about the chemical bonding in terms of quantum mechanical model. So, what is quantum mechanical model? Already we discussed. According to Schrodinger, that an orbit that consists of suborbit. Suborbit consists of orbital, right? So here when the two atoms coming close to each other. Suppose you think this is one atom, okay, which has let us say three cells are there, or two cells. Let us talk, okay, and this is another one which has also two cells are there. So when they're coming close to each other, what will happen? Now this is your orbit. So this orbit will overlap on another orbit, right? So when orbit and orbit are going to overlap, orbit consists of orbital. According to quantum mechanical model, orbit consists of orbital. So why can't the orbital can overlap? So this is suggested by your who is that scientist? Linus Pauling. Linus Pauling, in order to overcome the drawback of the previous theory, which we call as your the valence electron pair repulsion theory. Because the valence electron pair repulsion theory still depend on the covalent bonding structure or covalent bonding nature that is developed and put forward by G.N. Lewis, right? Still, it depends on that covalency, right? Or still, it depends on that your nomenclature of the covalence, right? Uh, Second point, the valence electron pair repulsion theory could not explain about the strength of the bond energy, and electronic nature of a covalent bond. Electronic nature of covalent bond. That's why that model or that theory only predicts what will be the structure of the molecule in covalent bond, because the covalent bond is strongly directional. That's why. Okay, so because of presence of the lone pair and bonded pair, uh, there is a angle described at the central atom, which we call as a bond angle. Okay, so in order to overcome that, Linus Pauling in 1954, Linus Pauling in 1954, he developed a theory which we call as or suggested a theory that we call as Valence Bond Theory, which is based on the quantum mechanical model or based on the orbital. That's right. We can call it as a orbital overlapping theory. Orbital overlapping theory, which is put forward by Linus Pauling in 1954. Now, the question is arising here. Whenever the two orbits are overlapping, they have so many orbitals. What are they? Now, S is there, P is there, D is there, S is there. So many type of four orbitals are there. Mainly you can take. Okay, mainly you can take four orbitals are there. So among all the four orbitals, F orbital, we don't know. What is the shape of F orbital? We don't know till now. Because the electron when entered into F orbital, almost all are radioactive in nature. All are radioactive in nature. That's why. Leaving about the F orbital, remaining three orbitals are there. What are they? The S, P, and D. Right. So SPD orbital of one atom can overlap with the same SPD with the another one. So there are so many combinations possible here. What is it? Now SS combination, SP combination, SG combination, again SP combination, PP combination, PD combination. Then the Sg combination, your DT combination, and DD combination. So in this lesson, we are mainly intend to go for only three type of overlapping. What are they? Now one is SS overlapping, second one is SP overlapping, third one is the PP overlapping we are going to discuss, and let us understand about the mechanism here. So the first point about the SS overlapping. The first one is your SS overlapping. So what do you mean by overlapping? First point is the overlapping. Overlapping is joining, or you can say superimposing of two. Superimposing of two. That we call as overlapping. Right? Okay. So what is SS overlapping? Now SS overlapping is nothing but s orbital of one element or one atom, it overlap with s orbital of another. S orbital of another. This overlapping we call as SS overlapping, which we observe in hydrogen molecule. So example is a formation of formation of hydrogen molecule by SS overlapping. A great example of SS overlapping is formation of hydrogen molecule. Already you know that. What here one hydrogen reacts with second hydrogen forming H2 molecule, right? And hydrogen is here nothing but the Z is 1, so electronic configuration is 1s1. So it is an unpaired electron in its s orbital. So that's why each hydrogen share one electron from their own side, right? Because this electron present in s orbital. So if you are representing this, so this is your 1s orbital, spherically symmetrical 1s, one of hydrogen, right? And this is another s orbital of another 1s1 of another hydrogen, right? So these undergo overlapping. And remember, whenever the overlapping is going to take place, uh, this your spinning of electron, or the spin of electron should be in opposite. Means both the elements should have opposite spin. Then only overlapping may take place here. So here one electron in the clockwise spin, another one is anti-clockwise spin. So these two s orbital they overlap. So when they overlap, how it will be? Now you check here. This is one, and this is the second one. So this is one s1 of one hydrogen, and another one s1 of another hydrogen, and this is the nucleus. This is another nucleus, and inside there is a pair of electron here. Right. This we call as SS overlapping. Now you can see because both are equally powerful. Equally powerful. So both are eating each other. Both are eating each other. That's why it will result the formation of a orbital like this. Because both are stomach will bulge. Because both are eating each other. Both are eating each other. Both are equally powerful. That's why this will form like this. So this is one nucleus, this is another nucleus, and in between there is a pair of electron which are in anti-clockwise spin. So this is a nothing but called SS overlapped orbital. Overlapped orbital in hydrogen molecule. Hydrogen molecule. So this we call as SS overlapping, where S of one orbital it overlap with another S of another orbital. So this is a very simple example of SS overlapping which is observed in the formation of water molecule. Sorry, formation of hydrogen molecule. Hydrogen molecule. So this is your SS overlapping. Okay. Coming to the second type of overlapping, we call as a sp overlapping. We call it as a sp overlapping. So what will be the sp overlapping? The sp overlapping, you can say that s orbital of one is overlap with p orbital of another one. So the second one we call as, okay, that is a sp overlapping, right? So s orbital of one, it overlap with the p orbital of another one. So what is the mechanism once we check? What is the shape of s orbital? So what is the mechanism? Right. So this is s orbital which is spherically symmetrical. Spherically symmetrical. It overlap with p orbital. What is the shape of p orbital? It is dumbbell shape. It is what shape? Dumbbell shape. So this is your dumbbell shape. This is your dumbbell shape. This is your either px or py or pz. Either px or py or pz. Right. So when they're overlapping, because p orbital is a little powerful than the s orbital, because s orbital is very close to the nucleus, so it has less energy. So p orbital has more energy than s. So you can say here, who is eating what? Who is eating what? So yeah, as you know very well, when the snake will eat the frog, the stomach of the snake is going to increase. It is going to bulge. So this is snake. This is your frog. This has more energy. This is less energy. So what will happen here? Now this will continue like this. So this is your s orbital and this is your p orbital. This is your p orbital, right? And there will be your anti-clockwise spin electron. So this is anti-clockwise spin electron here, right? So now you can observe P is eating the S. So whose the stomach will bulge? Now that is your what? P. So this will form like this. What it will form? Like this it will form. P is bulged now. The stomach of P is bulged now like a snake, right? And this is one nucleus. This is second nucleus, which have your a pair of electrons. This is the mechanism of sp overlapping. Sp overlapping, which is generally found in, which is generally found in your hydrogen fluoride, hydrogen chloride, hydrogen bromide, and hydrogen iodide. So in these molecules, this type of overlapping is found. And you can observe here how the overlapping is taking place. Here you observe how the overlapping is taking place. This type of overlapping we call as end on end overlapping. It is called end on end because one end of one orbital is overlapping with another end. That's it. This is also called this is called as end on end overlapping. It is also called as axial overlapping. Axial overlapping. So this overlapping also called as end on end overlapping, or simply we call as a end on overlapping also. End on overlapping also, or we call it as a axial overlapping. Axial overlapping, right? Which results a bond. This bond we call as sigma bond. What is this bond we call? Sigma bond, which is denoted by a Greek alphabet. This is called sigma bond, right? So this bond is also a what bond? Sigma bond, right? So how the sigma bond is formed here? You can observe here. The sigma bond is formed by the axial overlapping or end on end overlapping or end on overlapping between the two orbitals. Between the two orbital, right? So when two orbital head-on overlap occur, or n-on-n overlap occur, or axial overlap occur, right? So a sigma bond results. A sigma bond results. And Linus Pauling suggested that the extent of overlapping, it decides what will be the strength of the bond. What will be the strength of the bond? It is decided by extent of overlapping. So as here the extent of overlapping is more, this bond is a stronger bond. So that pointer which could not be addressed by uh, the electronic theory of valency or valence electron pair repulsion theory, which could not be explained. This is that point. One of the point is explained here. That is about the bond strength, about the strength of the bond by relating it to the extent of overlapping. Extent of overlapping. So if there is more extent of overlapping, strength of the bond is a more. Strength of the bond is a more. If extent of overlapping is less, then we can say it is a your uh, weaker bond. We can say that it is weaker bond. So here you can observe here the extent of overlapping is very high. It is a very high. That's right. A sigma bond is a stronger bond. A sigma bond is a stronger bond in comparison to other bond, which we are going to discuss later on. So, here another type of bond we are discussing here, that is called sigma bond, which is resulted by axial overlapping or n on n overlapping or n on overlapping or head-on overlapping between the two orbitals. Right. So these type of bond we can find in case of SS overlapping as well as SP overlapping. So you can take here, you can take the example of hydrogen chloride or hydrogen fluoride you take, because all are similar. All are similar. So hydrogen that is reacting with fluorine and it is forming hydrogen fluoride. Right. So both are non-metal. That's why both are not capable of donating, they are capable of accepting. So both are non-metal means the bond is forming by covalent bonding. So hydrogen is a 1s1. This is a 1s1 electron. And fluorine. What is the fluorine? Atomic number is 9. 9 means configuration will be helium and 2s2 and 2p5. Right. So you can observe here, s orbital is completely filled here, whereas p orbital is partially filled. Partially filled up. So px consists of a pair of electron, py also consists of a pair of electron, whereas pz consists of an unpaired electron. So this is a 2pz1. So this 2pz1 it overlap with it overlap with 1s1 and it will form a sp overlapping. So this molecule is a, you can say this sp overlapping in HF or HCl or HBr or HF or or HI, hydrogen iodide. So all are forming in the same way. So there we find the sp overlapping resulting formation of a sigma bond. Resulting formation of sigma bond. Right. So this is second type of overlapping. We discussed about the n on n overlapping. Okay. Coming to the third type. Coming to the third type, which we call as the PP overlapping. But the next one is called PP overlapping. Right. The third one is here the PP overlapping. PP overlapping. So what is PP overlapping? The p orbital of one overlap with the p orbital of another one. Now, how many degenerate orbitals are p has? A P has a three degenerate orbital. What are they? The one is Px, one is Py, one is Pz. And how they are related? You check what is the designation or what is the orientation. You can observe Px oriented about the x-axis, right? Py orient about the y-axis. This is your Py orient about the y-axis. Whereas Pz it orient about the z-axis. That means they are mutually perpendicular to each other. They are mutually perpendicular to each other like this. So this is the x-axis, this is y-axis,
Sir,
and this is, yes, tell me.
sir, your voice is breaking, sir.
Now can you hear me now?
Yes, sir.
Okay. So, so here what the now there are three axes are there. One is x-axis, one is y-axis, another one is z-axis, and all the axes are mutually perpendicular to each other. Mutually perpendicular to each other. So now, as there are different type of axes are there, their orientations are different. So what are the possible of a PP overlapping? So here there are two possibilities are there. What are that? One overlapping can take place that is called head on overlapping or end on end overlapping or axial overlapping. This is one of the options. This is one of the option which is occurring like this. So one orbital is overlapping with another orbital in head-on or end-on-end or axial, which results the formation of sigma bond. What bond? The sigma bond. Right. Okay. Second, if they cannot overlap, if they cannot overlap in axial, why? Let me tell you here. So let me show you a small example here. See here, I have three fingers here. So you can observe here, there are three fingers I kept like this, right? So all the three fingers are mutually perpendicular. Mutually perpendicular. So suppose this is X, this is X, this is Y, and this is your Z, right? So if X and X are undergoing your end on end overlapping, end on end overlapping. So what about the two? What about the two? So they cannot move. They cannot overlap in the same way. They cannot overlap in the same way. Why it is so? Because all three axes are mutually perpendicular. These three are mutually perpendicular. As the three are mutually perpendicular, if one of them undergo axial overlapping, the other two cannot undergo the similar one. So they'll go what the sidewise overlapping, or we call it is a lateral overlapping. Lateral overlapping resulting formation of another bond which we call as pi bond. What do we call it? A pi bond. So under PP overlapping, there are two type of bonds are going to form. One is due to end on end overlapping or axial overlapping. Then it will form sigma bonds. So how it will form? Now let you check the mechanism. This is found in your fluorine molecule, bromine molecule, and iodine molecule. Bromine molecule and iodine molecule. So this type of overlapping found in case of fluorine, chlorine, bromine, and iodine. All are same, right? So how it is a p orbital? If you take this is a p orbital and it overlap with another p orbital like this because both are dumbbell in shape. So both are equal powerful. Both are equal powerful. So what will happen? Now both will eat each other. So this consists of one unpaired electron and this consists of another unpaired electron. So now the overlapping is going to take place here, right? And second overlapping will take place here. This is one nucleus. This is second nucleus with a pair of electron overlapping here, right? So here This is also resulting the formation because this is also a case of N on N overlapping. So it also result sigma bond. It also result sigma bond because both are equally powerful. Equally powerful. So both are eating each other. Both are eating each other. As both are eating each other, what will happen? Both stomach will bulge. So that we are representing in the picture like this. Right. This is called the TP overlapping. This is called the TP overlapping, which is found in case of fluorine, chlorine, bromine, and iodine. So this is called TP overlapping. Right. And the resulting formation of what bond it is? This is sigma bond. This is a sigma bond. It is formed by axial overlapping or head-on overlapping or end-on-end overlapping. So how it is? Let us take an example here. Right. So formation of a fluorine molecule. So now already we have fluorine here. Okay. Or you take a chlorine molecule. You take the chlorine molecule. So what is a chlorine? Now one chlorine reacting with the second chlorine forming Cl2. Both are non-metal. So how they are forming? Now each chlorine is shortage of one electron. Shortage of one electron. That's it. Each chlorine sharing one electron. So what is the chlorine configuration? Let us check. Atomic number is 17. The electronic configuration is what the neon configuration, that is a 10 electron over, then 3s1, 3s2 and a 3p5. 3p5. So 3s orbital is completely filled with a pair of electrons, right? And 3p orbital is a partially filled now. So px is completely filled, py also completely filled, and pz has one unpaired electron. So your 3pz has one unpaired electron. So this overlap. This overlap. Right. So this will overlap with another chlorine. So this is you can write 3pz1 of one chlorine with another 3pz1 of a second chlorine, that is overlapping on each other and forming the Cl2 molecule. The chlorine molecule also form in the same way. Chlorine molecule also form in the same way. So examples are chlorine, chlorine, bromine, iodine. All have same. Chlorine has a 2pz, chlorine has 3pz, bromine has a 4pz, iodine has a 5pz. So the mechanism is same, everything is same. Everything is what the same. So this is one of the option of head on head overlapping, head on head overlapping or axial overlapping, which is resulting sigma bond, which is resulting sigma bond, which is found in case of chlorine, chlorine, bromine, and iodine under PP overlapping. Now, what is the second option of a PP overlapping? Where a p orbital cannot overlap in axial. So there another option can be observed, that is called lateral overlapping. So the second option under PP overlapping, that is called lateral. Lateral overlapping. It is also called as sideways overlapping. Sideways overlapping. This is a second type of overlapping observed in case of PP overlapping. Right. So this is coming under PP overlapping. Right. Right. So here a sideways means where end on end not possible. Where end on end not possible. So what is the mechanism? The mechanism will be like this. This is one p orbital. This is dumbbell shape. This is another p orbital of same dumbbell shape. This is the nucleus, right? So they overlap on each other. So what will happen now? You observe here, right? There is a second overlapping taking place here, right? There is a second overlapping. This is one nucleus. This is second nucleus, right? So this is a called a sidewise overlapping. This is called what a sideways overlapping, or we call as sidewise overlapping, right? Which result formation of a bond, we call it as a pi bond. This is called a pi bond, denoted by mathematical symbol that is called pi bond. So a pi bond is formed by sidewise overlapping. Sidewise overlapping. So here you can observe here the extent of overlapping is very less. The extent of overlapping is very less here in comparison to this. That's why a pi bond is weaker than a sigma bond, and it only exists. It only exists when there is a sigma bond already exists. Because already I told, if the orbitals are not capable of axial overlapping or head-on-head overlapping, second option is the sideways overlapping. Means already one should be engaged in this overlapping first. Means first of all, sigma bond should be produced first. Then only pi bond is possible. Then only pi bond is possible. So remember that the sigma bond can exist independently, whereas the pi bond exists when sigma bond already exists. Or you can say a pi bond exists in presence of sigma bond. Pi bond cannot exist independently. So it only exists when there is a sigma bond. When there is a sigma bond. Whereas a sigma bond can exist independently. So this one we represent like this. We represent like this. And this is one P, and this is second P, right? And we represent the bars. We represent the bars like this, because there are two overlapping here. This is one electron, this is second electron, right? So this your overlapping represented like this. This is a bar. This is your bar which look like pi, which look like a pi. That's right. This is called a pi bond. This is called what bond? A pi bond. So how a sigma bond results? A sigma bond is resulted because of the head-on overlapping or end-on head overlapping or a gel overlapping between the two orbital, whereas a pi bond is formed due to the lateral overlapping. Lateral means sideways overlapping or sideways overlapping. That results a pi bond. And here the extent of overlapping is more. That's why strength of the bond is more. Strength of the bond is more. But here the extent of overlapping is less. That's why strength of the bond is less. That's why a pi bond is weaker than a sigma bond. That's why it exists in presence of sigma bond. So it does not exist independently, whereas a sigma bond exists independently. A sigma bond exists independently, right? So this is your what a PP overlapping. So this we can observe here in case of oxygen molecule. In case of oxygen molecule, this can be observed, right? Both the bonds we can observe. As you know very well, oxygen is shortage of two electrons. Oxygen is a shortage of two electrons. So how it will form? So one should try yourself, right? So oxygen formation of formation of oxygen molecule, right? So one oxygen reacting with second oxygen, forming oxygen molecule. Right? Both are non-metal. So oxygen, the atomic number is 8. The electronic configuration we can write that is a helium configuration and 2s2, 2p4. Right? So it has a pair of electron in s orbital, whereas two unpaired electron in 2py1, okay, 2py1 and 2pz1. So it has a two unpaired electron. So it will share with the another two. That's why between oxygen and oxygen there is a double covalent bond. So each oxygen will share how many electrons? Two electrons from their side for the bond formation with the second hydrogen, and the rest of the electron will revolve around. Right? This is the oxygen bond formation. This is the oxygen bond formation. There is a double bond. So among these double bond, whether sigma bond is present or pi bond is present, that we are going to discuss in our next class. So this is the oxygen formula. So remember that in oxygen molecule there is a double bond. There is a double bond. Whether both are sigma bond or both are pi bond or one is sigma, one is pi, we can discuss in our next class because less time. So